Hi everyone, welcome to our day 2 training session of learning Oracle Goldengate 30-day challenge. My name is Ashish Agarwal, and I'll be delivering this lecture to you. So before commencing the session, just a quick round of update regarding my YouTube channel, which is youtube.com/Ashish Agarwal _GG. So if you haven't visited the channel, I would request you to do visit the channel and do like, share and subscribe the channel. The channel is dedicated to Oracle Goldengate related videos. Thank you. So in today's session, we are going to discuss about the day 2 session agenda includes Goldengate architecture we'll discuss. So how the data flow happens in Oracle Goldengate. Then we'll discuss about Goldengate certification matrix. Then we'll discuss about how to download Goldengate binaries. And if time permits, we'll discuss about installation of Oracle Goldengate. If it doesn't, then we'll move this topic to the next session, day 3. So in the previous session, we discussed about different types of architectures of Oracle Goldengate. So what are the different types of architectures available in Oracle Goldengate? Classic architecture and microservices architecture. So classic architecture is GGSCI based architecture and microservices is REST API GUI based architecture. So how does classic architecture work? So this training is classic architecture. Hence, whatever we discuss from now onwards, it is everything about classic architecture. Okay. So in Golden Gate is a replication tool which can replicate the data from one database to target. So you have source database and target database. So your source can be any Oracle or any supported non-Oracle database. So Goldengate not only it supports Oracle database, it also supports your non-Oracle database. Same way, your target can be any Oracle or any non-Oracle database as well. So each database has its own transaction logs. In case of Oracle, those transaction logs are called as redo logs or backup of redo logs, which are called as archive logs. So whatever changes happens in the database, those changes get recorded into redo logs. Now, those changes get recorded into the transaction logs. Now, as I mentioned previously in the previous session, that your transaction logs contains committed as well as uncommitted transaction. So whatever changes are written into the transaction logs, Goldengate captures only the committed transaction. So that your transaction logs would contain committed as well as uncommitted transactions. But Goldengate is going to capture only committed transactions. Once those transactions are captured, it will write them to the trail file on local machine. So these trail files are binary format files which resides on the operating system. Just like your archive logs, they reside on operating system. Same way, these Goldengate trail files will also reside on the operating system. So the extract process will capture the data and write them to the trail file on local machine, which are called as local trail. Once the data becomes available into local trail file, so the trail file residing on source system is called as local trail because it is local to the extract process. So the extract process captures the data, writes it to local trail. Now, once the data becomes available into local trail, Goldengate data pump process reads the data from the local trail, sends it over TCP/IP network, and writes it to remote trail on target database. So, extract process captures the data and captures only committed transactions. Write them to the local trail file. Once the data becomes available into local trail file, Goldengate data pump process reads the data from local trail, sends it over TCP/IP network, and writes it to the trail file on target machine. So the trail file on target machine, because they are remote to the source database, so they are called as remote trail files. Once the data becomes available into the remote trail file, the Goldengate replicate process reads the data from the remote trail and applies it to target database. So this delivery process or the capture process is also called as extract process. Delivery process here is also called as the replicate process. So as the session goes on now, we will use the term capture and extract interchangeably. Same way, we are going to use the term delivery and replicate as well interchangeably. So I again repeat, each database has its own transaction logs. So Goldengate is a CDC tool. CDC stands for change data capture. So whatever changes are happening on source database, they will be returned to the transaction logs. Once the transactions are available in the transaction logs, Goldengate extract process will receive the changes from the transaction logs and is only going to capture the committed transactions. Once those transactions are captured by the Goldengate extract process, it will write them to the trail file on local machine, which are called as local trail file. Once the data becomes available into local trail file, the data pump process is going to read the data from local trail, sends it over TCP IP network and writes it to remote trail file. Once the data becomes available into remote trail file, the replicate process will read the data from remote trail and applies it to target database. So there are three processes involved in Oracle Goldengate replication: capture or extract, data pump process, and the delivery or replicate process. So these processes are responsible for replicating the data in Oracle Goldengate environment. Okay, so remember one thing, because extract process captures the data, captures the committed transactions only. Hence, your local trail and subsequently remote trail will only contain the committed transactions, because extract process is writing data to local trail and it only captures committed transaction. So it means that whatever transactions are available into local trail or remote trail, those transactions are committed transactions only. Okay. Now, Goldengate is also supported in bidirectional environment as well. So bidirectional means is both the sites are live. The application can be connected to site A as well as site B. So whatever transactions happens on site A, they will be replicated to site B. Similarly, whatever transactions happens on site B, they will be replicated to site A using Oracle Goldengate. So Goldengate also supports bidirectional scenario as well. So bidirectional means both the sites would be live and Goldengate will apply the data from one site to another. Whatever site the transactions are coming on, they will be applied to the other site as well. Okay, so in bidirectional, what will happen is both the sites will be live. So whatever transactions are happening to whatever transactions are happening on site A, they will be replicated to site B. Similarly, whatever transactions are happening on site B, they will be replicated to site A database. So basically here, you have the site B database. Now, I always take one thing. Bidirectional is nothing but two-way unidirectional. Just like you consider it as unidirectional from site B to site A. Just like you have set up Goldengate from site A to site B, in the same way, you will be setting up Goldengate replication from site B to site A. So what happens is now for setting up site B to site A replication, site B database will have its own transaction logs. So it will contain the transactions, whether committed or uncommitted. Now, whatever transactions are present over there, the Goldengate extract process will retrieve the changes from the transaction logs of the database. Remember, it will only capture committed transactions. Once those transactions are captured, it will write them to the local trail file on site B. Once the transactions are available into the local trail file on site B, the data pump process will read the data from local trail, sends it over TCP/IP network and writes it to remote trail on site A. Once the data becomes available into remote trail, the replicate process on site A will read the data from remote trail and apply it to site A. So bidirectional is nothing but two-way unidirectional with some consideration. What are those considerations? We'll discuss during our bidirectional session. Okay. So pump process read the data from the local trail and write the data to the remote trail. So remember one thing. That is very good question, Sylvan. So Sylvan has a question which is very, very good. Does the pump process reach the individual transaction and then writes it to remote trail, or does it copy the trail file from source to target? So the answer to this question is C. If Goldengate pump process applies the trail file from source to target, then it won't be real time. Goldengate is real time. That means that as soon as the transaction is available into local trail, pump process will read it. It will read that particular it will send that data over the TCP/IP network and write it to remote trail on target side. Okay, so it will write the data. It will not copy the trail. So there are three processes involved in Goldengate replication. One is capture, second is pump, and third is replicate process. Each process has source to read from and a target to write to. So the capture process source is source database. Target is local trail. Pump process source is local trail and target is remote trail. The replicate process source is remote trail and target is target database. So each process in Goldengate has a source to read from and a target to write. Okay. So the data flow happens like this. The extract process is going to read the data from the local trail. Once the data is available into local trail, the extract process will capture the data, capture the committed transactions and write them to the trail file on local system, which are called as local trail. Once the data becomes available into local trail, the data pump process will read the data from the local trail, sends it over TCP/IP network and writes it to remote trail on target database. Once the data becomes available into remote trail, the replicate process will read the data from remote trail and then apply it to target database. So bidirectional is nothing but two-way unidirectional with some consideration. So yes, there are certain consideration, but we are going to discuss about those bidirectional scenarios. What are the considerations in the bidirectional topic? So that is also covered. So if you see the flow, so guys, this Goldengate architecture is really very important. The reason being, if you have to set up Goldengate, if you have to manage Goldengate, if you have to troubleshoot Goldengate, everything you can do from this architecture. This architecture is really very important to understand. And you can see the architecture contains only 5 or 6 components. It doesn't have many components. So it's very easier to understand, very easier to comprehend and implement as well. Goldengate itself, I always say one thing. Goldengate is one of the easiest technology of this world. You can learn it very well. You just need to give 30 days or 45 days and you can master Goldengate. But of course, just like other technology, yes, you need to practice. So because it is so easy, like see the architecture of Goldengate. It is pretty easy and straightforward. If I compare it with database, you won't believe it took me 8 months to understand Oracle database architecture. And also, let me tell you, when I started learning Oracle DBA, my first training I'm talking about, my teacher was very good. So she told me one thing, that if you have understood Oracle database architecture, you have learned 70% of Oracle DBA. But later on, because it was beginning for me, later on I realized that it has so many things still. But Goldengate architecture is nothing else. What you see in front of you, it's that only. So it's really very easier for you to understand this architecture and implement this architecture because it is so easy and no complexities are involved with this. Okay. So Goldengate architecture looks like this. You have an extract process, writing data to local trail, pump process. As soon as the transactions are returned into local trail, The pump process reads the data from local trail, sends it over TCP/IP network and writes it to remote trail, and then the replicate process applies. In bidirectional, both the sites are live. So whatever transactions are happening on site B, they will be replicated to site A. Whatever transactions are happening on site A, they will be replicated to site B. Okay. Now, in the previous session, we discussed one thing: classic extract and integrated extract. And many people had that question. What is the meaning of integrated extract? Or what is the difference between integrated and classic extract? Right. So let us discuss about that. So there are two types of extract. One is classic, second is integrated. So first of all, let us discuss about integrated extract. So integrated extract was introduced in Goldengate version 11.2.04. So to use the integrated extract, your database version, Oracle database version, minimum should be 11.2.0.3. And your Goldengate version should be 11.2.04. Okay. So now what happens in integrated extract is, in the integrated extract, let me tell you, first of all, it is tightly coupled with the database and it creates multiple processes inside the database. So what happens is, when you configure integrated extract, so the integrated extract basically configures internally logminer database. You don't have to configure anything on your own. Automatically it happens. So integrated extract requires registration to the database. And as soon as you register your extract process to the database, a logminer database gets built inside the database. So logminer is same what you use to read the archive logs of the database. That's the same. So logminer database gets built inside the database. Now, once the transactions are available into the redo logs or archive logs, the copy of those changes gets returned into the logminer database. So basically, logminer is nothing but copy of your redo logs and archive logs. Okay. So whatever transactions are getting returned into the transaction logs, that is redo logs and archive logs, the copy of those changes gets returned into the logminer. And then logminer passes on those changes to the extract process in form of LCR. LCR stands for logical change records. So internally there are some change records and they are logically internally converted by or captured by the integrated extract, and it writes them to the local trail file. So what happens in integrated extract is, I again repeat, you have a source database. That database has its redo logs or archive logs. Now, whatever changes you do, those changes will be returned into the redo logs and subsequently to archive logs. Right. Now, once those changes are returned into the transaction logs of the database, that is redo logs and archive logs, the copy of those changes gets returned into the logminer database. Now, logminer database will then pass on the changes which are required by extract process in form of LCR. LCR stands for logical change record. So logminer is exact copy of these redo logs and archive logs. So it will contain your committed as well as uncommitted transactions. So this logminer, if you have, I'm not sure if you have, but how do you read your archive logs of the database? If in case you have to read your archive logs of the database, how do you read it? You read it through logminer utility. So logminer, same thing, this same is this logminer database. So the copy of those changes gets returned into the logminer database. And then logminer process passes on the changes to the extract process, integrated extract process, and then that extract process writes the data to the local trail file. Okay, so so what does integrated extract do basically is, integrated extract retrieves the changes or receives the changes from logminer which are required by this extract process to capture. Okay. Now, let us discuss about classic extract. What is classic extract? So, logminer contains your committed as well as uncommitted transaction. So it will pass on the changes which are required by the extract process. So basically the part of capturing is done by extract process. Extract process will capture only committed transactions. Okay. Now let us discuss about classic extract to understand the difference between the two. To understand the difference between the two, the integrated and classic. Let us now discuss about classic extract. So what does classic extract do? So the classic extract, basically what it does, it reads the, so you have the transaction logs. Now your transaction logs will have transactions happening. So what happens here is the capture process reads the transaction logs in sequential manner. Okay. And it will capture only the committed transaction. Once those transactions are captured, it will write them to the local trail file, and then pump process will read the data from local trail and writes it to remote trail file. So basically what happens here is in the classic extract, your extract process will capture the committed transaction. So classic extract, basically what it does is it establishes direct connectivity with the database, and then it reads the transaction logs in sequential manner. Once the transaction logs are read in sequential manner, it writes them to the local trail file. So in the classic extract, it receives it reads the transaction logs in sequential manner, and then whatever transactions are committed, it will capture those and write them to the trail file on local machine. Okay, so the difference between integrated extract and classic extract is the log miner passes on the changes to the extract process. However, in case of classic extract, what happens is the extract process reads the transaction logs in sequential manner, and it is going to capture only committed transaction. Okay. Let me tell you one more thing. The performance of integrated extract is almost 5 times faster than the contemporary classic extract. So if your classic extract is working on some data, if it takes 10 seconds to capture the transactions, integrated extract will be able to capture it in 2 seconds. The rate of frequency, like I have done this test myself, capture process can capture up to 5,000 transactions per second. However, same type of transaction, same type of load, integrated extract captures 25,000 transactions per second almost. So the performance of integrated extract is 5 times faster than the classic extract. But I have a question for you. How come the performance of classic extract be slower than integrated extract, or how come the integrated extract be faster than the classic extract? Even though here in integrated extract, you have got one more layer in between of log miner, which passes on the changes. So basically in integrated extract, the extract process does not connect with the database directly. There is one more layer in between of log miner. So basically log miner will pass on the changes to the extract process. However, in case of classic, the classic extract is directly interacting with the source database. So how come the performance of integrated extract is faster than classic, even though there is one more layer in between in integrated extract? If I say logically upon being a new person, I would always think that classic extract should work faster, right? So how come the performance of integrated extract is faster than logminer? Would anyone like to answer this?
Is it because it's reading sequentially, the classic one?
Okay.
Because logminer is database's own process and extract is external process.
Okay.
Ashish, in Classic, it should look for committed and uncommitted transactions, but in case of logminer, only the committed transactions will be stored so that it is faster
No,
than Classic.
that's not the correct statement. Your
I think
logminer database is exact copy of your online redos and archive logs. So basically, your logminer also contains committed as well as uncommitted transactions. So that's not correct answer
but the
here.
log miner will transfer only committed transaction to the extract process.
Okay.
So
I think the log miner is directly connected to the database, although it collects both um committed and uncommitted. Since it's connected to the database and uses the log miner, so I think it's faster. But in the classic, might be slower because it's reading from the trail files.
No, it writes to
Oh,
the trail files. It's not reading
oh,
from the.
okay, got it.
Okay. Anyone else would like to
Uh,
answer?
The
So it
classic
uses some parallel
extract.
process
So Yusuf,
to.
you go first. Pankaj,
I'm
let
just taking
Yusuf
it.
answer.
It
yeah,
uses some parallel process to write the data in logminer.
No, so that's whatever it is. But still, that is the different point. But if I look at in a layman terms, if I show these two screens to a layman, definitely he will answer. Or even when for the first time I had this question, I did lot of research. Let me tell you, this answer, what I'll tell you, this you won't find in Oracle documentation as well. I did my own research based on that, I'll tell you. And what Vikas said, it's absolutely correct. So Vikas, so Mani, you were also Mani Williams. You were also trying to answer it correctly, but at the end you said trail file, so I won't consider your answer as correct. But you were to the point as well, but you were also fine. So the thing here is we have to understand one thing. In chat as well, people have answered. So let me check chat. Classic is sequential and need to read only committed. Okay. Okay. So the thing here is in classic extract, what happens is we have to understand one thing here. The classic extract is a process which is external to the database, right? It is not residing inside the database. It's not database part. It is an external process. See, we have to understand one thing. One thing always consider. Goldengate is a product which is external to the database. It's not part of the database, right? So this classic extract, it is an external process which reads your transaction log sequentially. So basically, it has to read the transaction log sequentially, and then it will capture the required data and write it to local trail file. However, in case of integrated extract, what happens is whatever data is required by the integrated extract, logminer process passes on those changes to the database. Logminer passes on those changes to the extract process. So basically, whatever transactions are needed by the logminer, whatever transactions are needed by the extract process, logminer will pass on those changes to the logminer, and logminer will pass on those changes to the extract process, and then extract process will write that data to the local trail file. So the whole concept here is the logminer process is doing the task, and logminer is doing the filtration, whatever filtration it has to do, and then it passes on those changes to the integrated extract, and then integrated extract applies that data to the local trail file. Okay.
Ashish,
Now one thing here is we have to consider that this integrated extract is basically tightly coupled with the database because of this logminer. Now you may ask the question, do we have to build this logminer separately? Now, anyways, this question will be answered for you when we do the setup. But just to give you a brief overview, as soon as you register your extract process, once you register your extract process, the logminer database build happens automatically. Okay, so you don't have to do any extra setup. The logminer build happens automatically here. I'll give you one example, like what like classic extract and integrated extract one. Why the integrated extract is faster. So basically LCR stands for logical change records. Now, Goldengate is a process which captures only application schema, application transaction. So Goldengate captures application transaction. So application transactions means is application tables transactions, whatever it is happening. So in application schema, whatever application tables reside, and inside that again, whatever transactions are happening, Goldengate can capture those. It cannot capture system or sys schema tables. Goldengate cannot. Remember that. It can only capture application data file. So suppose, consider a scenario. In a database, your transaction logs contain sys system, various transactions, right? So you have got 10,000 sys transactions going on. After that, you have 20,000 system transactions going on. After that, you have got two department tables. So basically, what we want is Goldengate extract process wants to capture the data from GG training 1 schema and inside that DPT table, and same way GG training 1 dot employee table. These two transactions, these two table transactions it want to capture. Now, your transaction logs contains 10,000 sys transactions, 20,000 system transactions. After that, it will find two department table transactions. Then again, it has 100,000 sys transactions, 100,000 system transactions. After that, it again has to read two employee table transactions. So basically, if it's classic extract, what it will do is it will read these transactions sequentially. So first it will read this 10,000 sys transactions, and then it will read 20,000 system transactions. After that, it will find these two department table transactions and it will write them to the local train. Same way, after that, again, it will find 100,000 sys transactions, 100,000 system transactions. So it will read those sequentially. And then after that, it will write two transactions related to the employee table. Now you can understand how much time consuming, how much performance impact your classic extract will have. Trust me, initially when there was only classic extract, we didn't used to feel that classic extract is performance is pretty low. But when integrated extract was launched, so what integrated extract does is basically logminer process will process these transactions. So because logminer is internal to the database, it is very quick. And that's why what it will do is it will read these transactions, it will ignore, it will read these transactions, it will ignore. It will find these two department related transaction. It will send to the integrated extract, which will write it to remote trail, sorry, local trail. Same way, after this, it will ignore these transactions, logminer, it will bypass these transactions related to system. And again, these two employee related transaction, it will send to the integrated. Okay. So Goldengate integrate. So you may be asked in interview as well that what the performance of integrated extract is faster than classic extract. What is the reason? The real reason is logminer. Logminer ensures, because logminer is a utility which is internal to the database, it passes on the changes which are required by the extract process, and then it captures those and write them to the local trail. So integrated extract, this what should I say? This test I have done myself as well. And that's why I can say that the performance of integrated extract is faster than the classic extract. Okay. Now, there is a question. When any process is external, there will be no load on database. In case of integrated extract, it is internal database process. So there will be extra load on database and performance might degrade. That is the wrong assumption, Yashwant. What you are saying is, again, logically, if you think, it may look correct. But see, you have to understand one thing. When something external is connecting to the database, you don't know how much performance impact it may have. Internally, logminer is internal process of the database itself. Internally it is. So it will not put any extra load on that. Even if it is, like, okay, if you have to consider, I should not say it is no impact, but the impact which it has internally on the database, it is minimal in comparison to your classic extract. I'll give you one example for it as well. The classic extract, when classic extract was there, it used to put almost 5% extra load on the database. But with this introduction of integrated extract, the load on the database is pretty less, and now integrated extract is very much used. Again, I should not say it is no impact. No, there is very minimal impact which you cannot even see as well. Okay, so your extract process will capture only committed transactions. So logminer will pass on only committed transactions to the target extract integrated extract process. Okay, so your integrated extract architecture. Now, Yusuf, you had replied this, which you were correct as well, that internally maybe integrated extract has multiple processes, which makes it faster. So yes, that's correct as well. Internally, Goldengate has lot of internally, the integrated extract has 4 processes which run. First is a reader, second is preparer, third is builder, and fourth is capture. So basically, another thing to answer this point, who said that? Yashwant, you said that internally, if there is any extra process, it should have some load. So internally, if you see, let me tell you one more thing. Internally, one integrated extract process consumes 4 processes at the database level. So there are number of processes which you can define at the database level. Limit, number of processes limit. If there are any, if you cross that limit, there cannot be any new connection made to the database. So internally, what happens is the integrated extract consume 4 processes. It takes 4 processes. What are those processes in the database? First is the reader, second is preparer, third is builder, fourth is capture. So basically, reader process reads the transactions, preparer process builds the logminer, preparer basically prepares the logminer, builder process builds the logminer, and then capture process captures the data, which is then sent to the extract process, which then subsequently write to the trail file. Okay, so internally there are 4 processes which runs in integrated extract. In classic extract, there is only one process which runs. However, in integrated extract, there are 4 processes which runs internally at the database level. So yeah, integrated extract is faster than the classic extract. There are multiple reasons, of course. First is the log miner, and second is internally there are multiple processes which runs. But logical explanation for it is the log miner process makes it fast. Log miner process basically does the task what your classic extract was doing. So whatever transactions are required by the integrated extract, log miner process passes on those changes and then it writes them to the local trail files. Okay. Yeah, Pankaj, tell me, you have a question?
Yes, actually you said, can you go to the notepad that systems is where?
Yeah, tell me.
Uh, can you open that one? That I, yeah. So, in the log miner, you said the 1000 of sys records, 1000 of system records will be ignored. But you said committed, uncommitted transaction will be written to the log miner. So, how it's going to be ignored?
So whatever transactions are required by the extract process is it will pass on those transactions to the extract process. So in
But it
Golden
will
Gate
be written
extract
to the log
process,
miner,
you
right?
can define what tables it can capture. So basically, again, these questions subsequently will be answered for you once we do the setup. Okay. So
Okay.
Golden Gate doesn't capture these sys or system transactions. Remember, it will capture only application schema related transactions. Okay. Now, does it mean integrated extract process will ignore as soon as it finds any transaction other than application schema? It will just skip. So any system related or sys related transaction. So basically, Golden Gate captures only application schema transaction. Okay. Okay. So now let us discuss about when you have to install Golden Gate. What are the considerations you have to do? And what are the things you need to consider? Okay, so the next topic is installation of Oracle Goldengate. So installation of Oracle Goldengate includes two parts. Installation of Oracle Goldengate include two parts. First is download of binaries, and second is installation of binaries or installation of GG software. Right. Now, where do you install GG software? You install GG software on the server. So basically, say for example, you have been hired as a Golden Gate consultant. Okay. Now, they have the servers in their environment. Now, they don't have Golden Gate. So basically, you have to start from the scratch. You have to give them Golden Gate requirement for the server. Like, sorry, what the server requirement for the Golden Gate. You have to give them. You have to provide. So you have to basically start from the scratch. So when you are installing Oracle Golden Gate, what are the points you need to consider? So basically, we are first of all discussing about installation consideration. So basically, we need to get the server ready for the Golden Gate. Because see, if you just install Golden Gate on any machine, and if at the end of the day performance of Golden Gate is not good, or you don't have space, you didn't do any analysis on the server, whether the server has space, whether the server has, whether the server can tolerate Oracle Golden Gate, the extra software on the server or not, or whether the server memory is properly allocated or not. So you need to ensure that your server should be ready prior to installation of Golden Gate. So before you proceed with installation, first of all, you need to define a location where you want to install Oracle Golden Gate. Okay. Before proceeding with installation, you need to define the location where you will install Oracle Golden Gate. So either you will install Golden Gate in separate mount point, you will define either you require a separate mount point, or you can install Golden Gate in existing mount pointers. Right. So either you can define in Golden Gate in, say, for example, slash Golden Gate, or you can define Golden Gate in existing mount point like slash U01 or slash data. Right. You can install Golden Gate in either of the two. So it's up to you. There is no recommendation for this. If you want to install it in separate mount point, it's okay. If you want to utilize any existing mount point, you can do that. Now, second thing, what you need to consider is how much space you require for installation of Oracle Golden Gate. Because see, another important thing is, say for example, you have 20 GB or 50 GB today, but you have to do the future analysis as well. At least for next 2 to 5 years analysis you have to do. You have to consider how much your Golden Gate would grow, how much space requirement would grow. Today it may suffice the space you have, but you have to do future. You have to do analysis and designing based on future as well. So you need to understand the requirement for the same, and for that purpose, what you need to do, you need to do research. What How do you calculate the space? I'll discuss with you in next few minutes. Okay. So the requirement is how much space you require for installation of Golden Gate. Basically, how much space you need in Golden Gate mount point where you are going to install Golden Gate. Because see, Golden Gate has trail files. The major chunk of Golden Gate is consumed by these trail files. And these trail files are binary format and they consume your hard disk space. Okay. And you also need to keep the backup of the trail files. Like you cannot just generate the trail files and delete them. There has to be, just like your archives, you have some purging policy defined. Same way for Golden Gate trail files as well, you require to have some purging policy defined. Okay. So now
Ashish,
you need a sufficient space in your environment so that your so that your Golden Gate trail files can suffice or Golden Gate software can stay. Now, what are the hardware requirements for installation of Golden Gate? First question comes, how much CPU Golden Gate needs? So for running Golden Gate, your 4-core or 8-core CPU is fine. In fact, it will run with 2 cores as well. But as per my experience, like when I do designing as well, and when my recommendation is asked, I always ask for minimum 4 cores or 8 cores. Second thing is space requirement, like how much should be the mount point size, whether you want to add your new mount point or you want to use existing mount point. So for space calculation, each person, you may have some different calculation criteria. I have some different calculation criteria. So in this section, let us discuss about how to calculate space requirement for Oracle Goldengate. So for space calculation, what I do is for last 30 to 60 days, I analyze the archive log generation per day. So for last 30 or 60 days, let us consider last 60 days. I'll check how much archive log generation happened per day. So one day it could be 20 GB, another day it could be only 1 GB, another day it could be 100 MB, or on one day it could be 100 GB as well. Right. So what I do is I do average of 7 days highest archive log generation. So out of the last 60 days, I find out the highest archive log generation days. Say for example, one day it was 100, another day it was 200 GB, then it was 20 GB. So what I do is I will find out 7 highest archive log generation. That is, out of 60 days, I'll segregate or I'll filter out those 7 days when the archive log generation was. And then out of those 7 days, I'll take the average of those 7 days. Okay. So suppose the average comes out to be 25 GB. Right. After that, generally what we do is we keep 7 days trail files on the system. We generally, like, it is an unsaid rule. If your client provides you different requirement, like he wants to keep 3 days trail files on the system. So this space calculation we are doing for archive logs, guys. See, Golden Gate extract process captures the data and writes to local trail. So this local trail consumes your hard disk. So what space calculation we are discussing right now? We are discussing about trail file. So basically, the major chunk of Golden Gate mount point is consumed by the trail. 50 to 60 to 70% consumption is done by the trail file. So we take out average of 7 highest days archive log generation. So suppose the average comes out to be 25 GB. After that, what I do, I multiply it by 7. Means I multiply it by number of days you need to keep the trail files. Suppose you need to keep the trail files for 7 days. This is the unsaid rule. Generally, we keep the trail files for 7 days. Okay. But if your client has different requirement, like he want to keep the trail files for 15 days. So multiply this average by 15. So suppose I want to keep it for 7 days. So what I'll do, I'll multiply 25 by 7. Once I get 175 GB, 25 into 7, 175 GB. Then I multiply it by 2 to 5 times. I multiply it by 2 to 5 times. So we will require 350 to 900 GB of. So I would request them for 900 GB of space. If you're comfortable asking for 350 GB, you should ask 350. Like if you think that your client is really low on budget, but generally I ask for 900 GB. And if they have to, some client may ask you for the justification for this. Like, why do you need 900 GB of space? I will tell them that I'm doing future analysis as well. Like this space, what you are doing. So if I give them 175 GB, you will require next set of space tomorrow only. I don't want to come into that situation, right? So that's why I'm providing them next 3 or 4 years calculation criteria, and then I'll request for this much space. So this much space will be sufficient for Oracle Goldengate. Every person, guys, remember one thing. This is my way of calculating the space. Some people, what they might do is they might take out like highest archive log generation day, say for example 200 GB, multiply it by 7, and based on that they may request for the archive log. They may request for hard disk, hard drive space. So everyone has different criteria for space calculation. It's not like I'm correct or they are wrong, or they are wrong, they are correct, I'm wrong. No. Each person, each Goldengate administrator has his or her way of calculating things. So this is my way, what I'm telling you. But if you have some other way, definitely you can go for it. Now, so first is CPU, second is space requirement. Then another thing, what you need to consider for before you install Oracle Goldengate is which OS user to use to install Oracle Goldengate. Right? Which operating system you are going to use to install Goldengate. Whether you are going to use Oracle or any other user apart from Oracle to install Goldengate, like ggAdmin or GG. So if DBAs are going to manage Goldengate, then you can install Goldengate with Oracle. But if Goldengate and database administrators are different, like say for example, the DBA team is different and Goldengate team is different. Basically, Goldengate team is not assigned to work as a database administrator. In that case, what you will do is you will install Goldengate using GG user or GG admin or any other user, but ensure that this user should be part of OInstall group. Okay. So either you can choose Oracle user or the user with which you have installed Oracle database in the environment, or you can choose any other user as well, apart from database user. Okay. So these are the considerations you need to put before you can install Oracle Goldengate. Okay. So in our case, the virtual boxes which are shared with you, these virtual boxes are the ones which already have the hard disk space defined and du-kh. So we are going to install Goldengate under /data, and we'll use Oracle user to install. It's up to you. If you want to use any other user as well, you can do that. Just ensure that that user is part of OInstall group. And another thing is space requirement. So if you check the space, we have df-kh dot. We have 82 GB available because this is a testing and development environment. So we have sufficient space available in our environment. Now, So once you have sent your requirement and your server is ready, the next step comes is downloading Oracle Goldengate. The next step comes is download of Oracle Goldengate. But again, downloading of Oracle Goldengate involves two steps. First is checking the certification metrics, and then based on that, download the software. So check the certification metrics based on your server requirement, based on your server OS. So before you can proceed to download Goldengate, you need to check the certification metrics. So what you need to do is you need to identify source database type like Oracle or SQL Server or anything, then version, and then OS platform. Same way, you require to note down this. Source database type, source database versions, and source database operating system platform. Same way, you need to require target database type, target database version, and target database OS platform. So in our case, we have got Ggate 1 and Ggate 2. So the database type is Oracle. Version is 19C. We can check what type of version it is. So it is 19C. And the OS platform, we can check the OS platform as well. The OS platform is uname-a. The OS platform is Enterprise Linux 7. This is the OS platform. So we have Enterprise Linux 7. Same way, the target as well in our case is same. Oracle version is 19C and OS platform is Enterprise Linux. Okay, so once you have identified these, next is you need to check the certification metrics as well. You need to check the certification metrics as well. So how can you check the certification metrics? To check the certification metrics, go to Google and type Fusion Middleware certification metrics. So Goldengate is Fusion Middleware product. So go to Google, type Fusion Middleware certification metrics. Click on the first link you get. Oracle for Fusion Middleware supported system configuration. So here, what you need to check is, you need to check your certification metrics. So basically now, here you will find the certification metrics for 21C Goldengate, 19C Goldengate, 18C Goldengate. So one question which I get regularly asked is, which version should we download? So before you can download any version, check the certification metrics, whether that is supported or not. So check the latest version certification metrics, which is 21C. Check whether it is supported as per your requirement, as per your environment or not. So check, download the certification metrics here. Open it. Start downloading 21C certification metrics. Once you download the certification metrics, go to Goldengate. Here you will find, now the next question comes is, which database this Goldengate 21C supports. So you can find it from certification metrics, which databases this certification metrics would support. So you can check so here you should check which databases this Goldengate 21C supports. So this 21C supports Amazon Aurora MySQL, Amazon Aurora Postgres SQL, MariaDB, MySQL, Oracle, Postgres, SQL Server, then other database as well. Google Cloud SQL for SQL Server, IBM DB2 for MySQL HeatWave is supported. So it supports these many databases, Teradata. Now, suppose if your database, if you want to check whether your database you have, whether Goldengate supports that or not, right? So what you need to do is, suppose 21C doesn't say that. So check 19C certification matrix. If 19C also doesn't say that it supports your database, then go to 18C. Go to 12C, 12.3 certification matrix. Go to 12.2. So it just means that 21C may not be supporting it, but the other versions may be supporting it. Okay. So yesterday someone asked the question, I think Sylvain it is, if I'm not wrong, that does Goldengate support, Goldengate 19C supports Postgres? So what you need to do is, you need to check the certification matrix, and based on certification matrix, you can identify whether it is. Okay. So here, what we are going to do is, our database is Oracle. So we'll select here Oracle database. So here we'll select Oracle database. Oracle database. And then you can see, so our platform is Enterprise Linux 7, right? Our platform is Enterprise Linux 7. So we'll move towards the right. So here is the processor type at OS version. So processor type is Linux x86 64. And so I'll select the processor type as Linux only. So I don't want Microsoft. So if you see now, I'll get the list here. I'll get the list now. So this is the list which Goldengate 19C supports. So Goldengate 21C supports. So Goldengate 21C supports Oracle database 11.2.04, 12.1.02, 19C and 21C, whether it is source and target, and it supports both classic and microservice. So you can see that. And it is supported on Oracle Linux 7, Red Hat Enterprise Linux 7, and Red Hat Enterprise Linux 8. So once you have identified that Goldengate 21C supports the database which we have, the platform which we have, the database version which we have, then what we can do is, we can proceed to download Oracle Goldengate 21C. Okay. So in the next session, what we are going to do is, we are going to discuss, or we are going to start with Goldengate download of Goldengate binaries. So which we'll do is, in the next session, we'll discuss about download the Goldengate binaries, and also we'll discuss about Oracle Goldengate 21C installation. So the next session which we are going to do will be on Monday, 3rd of June, next week. And the session will be conducted the same timing as per Eastern time. And the next session will be, as per India time, will be on Tuesday, 4th June. Okay. It will be on Tuesday, 4th June, and the timing will remain same. So in the next session, we are going to discuss about download the Goldengate binaries and Oracle Goldengate 21C installation. We'll discuss about Oracle Goldengate installation, difference between 21C and 19C. Then we'll discuss about decide where to install Goldengate and different options, like what is Goldengate Hub. We'll discuss about that as well. Then we'll discuss about prerequisites to set up Goldengate. And if time permits, we'll also discuss about what is supplemental logging, type of supplemental logging is. So prior to the next session, what you have to do is, you have to create the VMs. Link to will be different than the one. So we'll be sharing that with you 24 to 48 hours before. So in today's session, we discuss about Oracle Goldengate architecture, how data flow happens. So all the process in Goldengate work independently from each other. So there are two types of extract process, classic extract and integrated extract. So classic extract is there since beginning. So in this training, what we are so before you proceed to download and install Goldengate, always check the certification metrics. And before you can download and install Goldengate, always ensure that you check the source database type, source database version, and source database platform as well. We also discuss about installation considerations as well in this session. So we discuss about like what are the hardware requirements and space requirements related to Oracle Golden. Okay, so let me take questions which are there. So
So, Ashish,
is this, let me check the questions which are there on the chat. So is this supported like source has lower GG version and target has higher GG version? Will it have compatibility? Yes. So the best part with Goldengate is your source can be on lower version, target can be on higher version. So source can be on 11G, target can be on 21C. Source can be on 21C, target can be on 11G. Goldengate wise, as well as database lower and higher version compatibility is also there. So your source can be on source database and Goldengate can be on lower version and target can be lower and higher version. Same way your source can be your source database and Goldengate can be higher version and target can be lower version. Okay. And if we have rack environment where we need to install Goldengate, so we haven't done installation yet. So we'll be discussing about installation in the next session. Now, can we install Goldengate in application server as well if DB application is in different server? The answer to your question is yes. What is that? How can we do that? We'll discuss about that in the next session. So basically your Goldengate can be installed in other server apart from your database server as well. Now there is a question, what if source database not in archive log mode? Let me tell you one thing. For Goldengate to work, your database has to be in archive log mode. If it's not in archive log mode, it will not work. Okay. Okay. Yeah. If you have any question, you can unmute yourself and ask.
Ashish.
Yeah, Imdad, tell me.
So Goldengate, when it reads redo log files and when it reads archive log, any particular time it reads redo log, or any time it cannot read redo log file and then it read archive log.
So with the
Any
introduction of this integrated extract, it doesn't read, Goldengate doesn't read your archive logs or redo logs. It directly fetches the data from the, or it directly receives the changes from the logminer database. So your logminer requires your redo or archive because it is copy of your redo logs. Okay. Now another thing is, in case of classic extract, it can use your redo logs or archive logs based on how fast it is moving. So if it can match the speed of redo generation, that it will directly read the data from redo logs. But if your classic extract has some, like your redo log generation is higher or is going at the higher speed, then it can match it, which it can't match, then it will directly read the data from the archive log. So it will do that switch automatically.
understood. Thank you.
But that applies only to classic extract. Integrated extract reads the data or receives the changes directly from the logminer. But that doesn't mean that it doesn't need your redo logs or archive logs. The ultimate source always remains your transaction logs of the database. Okay?
Yeah.
Yes,
Ashish,
Ashish, got it.
Ashish, one question. When the integrated extract, in the integrated extract, logminer will capture both committed and uncommitted transactions, and it will send to the extract process. Then extract process will decide which one it will take only the committed transactions and it will write to the local traces. How it will be?
The logminer will pass on only the committed transactions to the extract process.
Okay. But earlier you said the logminer will send both committed and
Logminer
uncommitted.
contains both committed as well as uncommitted transactions, but it will send only committed transactions to the extract process. So if you have a look at this diagram, let me open this. So you see, so basically your log miner is copy of your redo logs or archive logs, right? So whatever changes are there in this redo transaction logs of the database, log miner is copy of that. So log miner will pass on the committed transactions to the extract process in form of LCRs, logical change record. Okay.
Okay. Okay, got it. Actually, a little bit confused where yeah, got it. Yeah.
Okay. Any other question anyone has?
Ashish, in case of classic architecture, extract process directly connect with the database, and only it will take only uncommitted transactions, and the extract process will take that and it will write in the local drive file, right?
Uh-huh. So Goldengate extract process will always write only committed transactions. So basically your local trail file will have only committed transactions. There will be no uncommitted transactions in your trail.
Okay. So that is what I'm saying, that it will look for the committed transactions in online and redo log file, online and arclog files, right?
Yeah, correct.
Okay.
Thank you, Ashish, for the crystal clear explanation of everything.
I hope it's the guys. This thing is really very important. I'll tell you why I introduced this installation consideration and other things. And earlier, what I used to do was I directly used to show the installation. But later on, I realized that it is very important because see, upon completion of this training, you might be hired or you might be working as an independent consultant for Golden Gate. Now, when you are working as an independent consultant, what happens is you are asked to design Goldengate. Basically, you're working as a Goldengate architect. So it's your responsibility to design the server as well. What server requirements are? This happens to me as well. So what you can expect in real time industry, I'll try to provide you that information. I'll try to provide like means I have worked extensively on Goldengate. I have implemented Goldengate and I'll complete 1100 projects by next month, by June end. So I know what it takes related to Goldengate, what kind of things you can expect in Goldengate industry. And that's what I try to provide. Okay. Yaman, do you have a question? Like I see your hand is raised.
Yes, sir. Why you mentioned that Golden Gate will not work in no archive log mode? I just want to understand why, because redo logs are getting written.
Yes. But Goldengate, okay. In terms of integrated extract, it won't work at all. In case of classic extract, it can work, but you will have data loss. So that's why we say it won't. So if you don't have your archive log, so I'll tell you about integrated extract. In case of integrated extract, if your log miner has to be built. If your database is not in archive log mode, you cannot build log miner database. Hence, in case of integrated extract, it won't. In case of classic extract, if your database is not in archive log mode, yes, it will work. But because if your archive log, if your if it's OLTP database, in that case, your extract process, if it cannot match the speed of redo log generation, then it will not work at all. So that's why we say Goldengate will not work in no archive log. Okay.
Yes, yes, sir. Thank you.
Ashish, Shamant here, Ashish.
Yeah, tell me.
Yeah, Ashish, this is regarding the classic architecture and integrated architecture. No,
Okay.
so
Okay.
if the
So
customer
there is
wants to
okay.
implement,
Wait, Shamant, wait. There is no
sorry,
integrated architecture at all. There are only
okay,
two types of architecture: classic architecture and microservices. So
okay,
if you have to ask question, please rephrase your question.
okay. So like the customer will know
No,
which one
no,
is
no, no.
which one we are
No. Okay,
implementing,
Shamant,
or
wait. Again, I ask, what is your, can you rephrase your question from beginning? Guys, the reason, Shamant, like, and others as well, why I'm asking you to do this is, I want you to use the correct terminology, whether you are talking to yourself, whether you are talking to your colleagues, whether you are talking to your client. You have to show that you know everything. What you are telling, you are confident on that, and you are using the right terminology. So, Shamant, yes, please rephrase your question again.
Okay, coming to this microservices and the classic architecture. So, in terms of organization, like if I want to suggest to the customer, so which one I can suggest, like whether classic architecture or the microservice, which one to be suggested, like to be more like to be more interactive or more feasible to the customer. So in terms of implementation, I am talking about.
See, both will work. So the features what classic architecture provide or what microservices architecture provide, both are same. Only difference is classic architecture is there since beginning, and it is completely command prompt based. Microservices is REST API based architecture, whose one of the feature is GUI. So both will work. The difference is like classic architecture post 21C will be deprecated. So if there are any new implementations, so subsequently, not today, but either after 2 years, 3 years, or 5 years, you might have to upgrade. You will have to definitely upgrade from classic to microservices. So if you have to consider that way, you can choose microservices. But if you want to choose any of the two, you can choose, like, if there is an option, you can choose any of the two. But considering the future, yes, and then your decision also depends on your team as well, like the team who is working, what their capability is. Are they more comfortable with classic or more comfortable with microservices? The reason why still the market share of classic architecture is much higher than microservices is because, first of all, the number of Golden Gate administrators who have Golden Gate knowledge are less in the market. But still, if people have Golden Gate knowledge, very less number of people are there, or consultants are there, which have microservices. So what they do is internally they will always suggest classic architecture. Hence, classic architecture is more famous. But
And
again,
one,
to answer your question,
yeah.
which one you have to suggest? You can suggest any. But if you are going to use classic architecture, probably within 2, 3, 4, 5 years, you might have to upgrade to microservices.
Okay. And one last question, Ashish, like is it work on PDB, CDB that we have recently there now? So how we can, it's works the same Golden Gate capture will occur in PDBs and CDB.
So in this training, we are going to discuss about how Golden Gate works in multi-tenant architecture.
Multi-tenant, yeah,
So
that's what
this
I'm.
question will be answered for you in subsequent. By next week, you should have answer for it. So, guys, there is, like, so far we have just discussed about introduction to Golden Gate and Golden Gate architecture. There is a lot of excitement to come, lot of exciting things to come, lot of learning to come. Like in this training, you will get in and out of Golden Gate. So you will have very good knowledge, understanding. So wait for a few days. We'll run step by step. We'll conduct these sessions step by step, and all our questions will be answered. Okay. Okay, yeah, Prasad, your hand is raised. You can ask.
Yeah, I have one quick question. So I'm trying to understand difference between the classic extract process and integrated extract process. So in your notes, you said that you have a process. Let's say you have a database transactions 10, system 20 Cs, and then DPT table, department table 10 transactions. So in case of extract, classic extract, it will go through first 10 transactions, go through them, and then say that okay, it's not, we don't need to replicate, we don't need to write it to extract process, and then it will go subsequent transactions sequentially. Whereas it comes to integrated, is straight away it skips the sys and system and directly goes to the department transactions. Is that what it is? Difference?
Correct.
Okay. All right. Thank you.
Okay. So yes, correct. So this is the difference between integrated and classic extract. So guys, there might be a question, and I have heard it from my students. That's why I again clarify. For you don't have to build anything separately for creating this log miner. As soon as you register your extract process, there are steps to create the integrated extract. So once you create your integrated extract, automatically your logminer build happens in time. Okay, so in the next session, we are going to discuss about download installation of Goldengate and difference between installation of Goldengate 19C and 21C. Okay, thank you. Why do I say you to check the certification matrix? Even so, I'll give you one scenario. In one of the project, there was one consultant who was working. He downloaded the Goldengate version. I think it was 19C, and it was Solaris platform basically. At that time, Goldengate 19C was not supported for Solaris. But he downloaded without checking the certification matrix. He just downloaded the Goldengate version. Client was there, and he was the consultant working. So when he downloaded, he found out that it is not working. He's unable to run Goldengate at all. So what he did, he raised the certificate, he raised the SR with Oracle, and Oracle said that this is not a certified version. They provided the certification matrix. So you might say, what happens? He found out the answer. But the thing is, in front of client when you're working, you should have the goal of right first time. Right. This is the basic thing which you or someone else can mitigate. Right. Like being embarrassed in front of someone else, it's not about embarrassment, but it's about like when we are hired as a consultant, we have some respect, we have some dignity. Client has full confidence on us. Now, if we do these kind of small things, right, these small things really matter, right? So you have to, it's like we are humans and we are error prone as well. I do make error. I I myself has truncated a table in production environment. I myself has done different mistakes. But the good part is I try to learn from my mistakes. So same thing should happen, and I try to tell you what mistakes I did and what you should not be doing or repeating it. So that's why it's always good that you check the certification matrix for any product before you proceed. It takes hardly 5 minutes for you, and you also get to learn something, right? So always check the certification matrix, and that's it. So on that note, let us end our session for today, and we'll continue in the next session. And with each session, I'll try provide you a lot of tips, lot of practical scenarios we'll be doing. So we have done just 2 days of session so far. There is a lot of exciting things which are going to come. Thank you very much, everyone, for joining.